Hello guys, what's up? This is Teacher Nicoy again. So we're here at General Mathematics first quarter, week 7, day 1. Okay, so today you will be able to solve the word problems involving exponential functions, equations, and inequalities. So the topic is to solving word problems involving exponential functions, equations, and inequalities. Okay, so let's go directly to the lesson. Okay, so in this lesson, um, we will be tackling about the any quantity that grows by a fixed percent at regular intervals and said to the process and is said to possess exponential growth. So there's a pattern in growing with fixed percent at regular intervals. So we will be using this formula. So just memorize this formula, and all of these exercises can be solved with this formula. Okay, so just like this example, so I will not be tackling about this example because I know that you can read this and it is easier to understand by trying to read that. And here we have this bacteria. Okay, so bacteria it is growing, and rate bacteria splits into two new cells, then doubling. Okay, so our main what you call that our main word to identify if it is the rate is this double. So if we say it doubles every time, so it has the rate of 100%. Okay, so let's remember, if the rate says that it doubles, it means the rate is 100%. Okay, so let's go here and let's try this one, but I will not answer what you call that exactly this one, but let's erase one number. Okay. So there's still a challenge for you to answer the exercises. Okay, in 2002, the population of school children in a city was 9,000. This population increases at the rate of 2% each year. What will be the population of school children in the year 2010? Okay, so this is how to answer it. So number one, first you will need to find the a, because we know that our formula is a 1 plus r to the power of t. So you need to find this a first. So what is a? Okay, so a is so a is this one, 99,000. This is your population. Then rate, what is your rate? So almost all rate has percentage on it, like this one. Okay, so 2%, and we change it to decimal, it is 0.02. Then the time, of course, the time has said year, or you know what time is, minutes, months, like that. So it is 2010 minus 2002. So why did I minus it? Because it is from 2002 to 2008. So how many years does is between 2002 and 2010? So we have here 2010 minus 2002, it is 8 years. Okay, so now we substitute it to our formula. So let's zoom in a little bit here. Okay, so our formula is a, which is 9,000, times 1 plus our rate is 0.02 to the power of 8. Okay, so let's move it aside here, and then we will go to our calculator. So we have here 9,000 times 1 plus 0.02 to the power of 8. Okay, so you have here the answer already, which is 10,544.93. So the other part here is already rejected because we all know that especially when we're talking money, you just need two decimal points. But if we're talking about population, hey, we're talking about population here. So population means it is not a decimal number, or I mean, there's no point 02 right there. Because population, just like humans, there are 2 person, there are 3 person, there's no such thing as 3.2 persons, right? Okay, so what we have here, the answer is 10,544.93. So if we round off it, it will become 10.54 10,545. Unfortunately, if we round off this one, it is for the future, right? It will be for 9 years. So we should not round off any number. So this will become y is equals to 10,544. All right. Okay, so that is the answer. Okay, we go to. Okay, so now we go to number 2. Okay, let's zoom out a little bit. And we have here number 2. Number 2, let's erase another number here. Okay, so Janine owns a chain of fast food restaurant that operated 20 stores in 1999. If the rate of increase is 8% annually, how many stores does the restaurant operate in 2007? Okay, so let's go back to our formula, which is a 1 plus r to the power of t, and then we have here our a is 20, which is this one, this number of stores, and then our rate is, you will know it has always percentage. 8% is equals to 0.08, and then our time is from 2007 minus 1999. So this is equals to 8. Okay, then we substitute it to our formula. Okay, so let's zoom in a little bit here. Okay, so we have here y is equals to, let's put it in a little bit lower. Y is equals to 20 as our a times 1 plus 0.08 as our rate to the power of 8. So y is equals to, so we have here our calculator. So our calculator is powered by Desmos.com scientific calculator. All right. Okay, so we have here 20, 1 plus 0.08. So our answer is 37. Okay, so we're talking about here about number of stores, right? So there's no such thing as 37.02 stores. So there's just 37 stores, and we cannot round off it to a much higher because it will be for another year. Okay, so we have here insects. So let's have here, I will have to erase one, so I'll be erasing this wait, number 2. So we have here 5 insects. Okay, so the number 3, the number of insects in a colony doubles every month. At present, there are 5 insects in the colony. About how many insects will there be in the colony after 3 months? Okay, so that is our number 3. So we have here once again our formula, which is like that, and then we have a. What is our a? So first is the number of insects. So initial number of insects, which is 5, and then our rate is, we all know it has this doubles every month. So doubles means 100%. And then our time is, we have here 3 months. So this is 3. Okay, so let's zoom in a little bit here. Alright, so okay, let's just substitute it. 5, 1 plus r, which is 100%, also known as 1.00. So 1 to the power of 3. Hey, this is supposedly time. Okay, so y is equals to, so let's go back to our magic calculator, I mean scientific calculator. So we have here, we'll just edit this one, 5 plus 1 to the power of 3. So we will have 40 insects. Okay, so if you want to use this is desmos.com scientific calculator. So you can use this one to make like this calculator more easy and fast, no? Because yeah, you have it now. There's no shame in using technology, right? Okay, so that's it for week 1. I mean week 7 day 4, week 7 day 1. Okay, so now we are at week 7 day 2. Alright, so we have here in this one is to solve problems, still to solve word problems involving exponential functions, equations, and inequalities. So we have here in this day, we will be discussing about the case and the case. Okay, by a fixed percentage at regular intervals. So this is our formula. So you can see, instead of having y equals to a1 plus r to the power of t, that is, it means that this one grows, right? If we talk about decay, so it will become minus. All right, and then so this is an example. You may try to read this. Okay, so another word is depreciates. Okay, so here we have here half-life. Okay, so if we're talking about half-life, it means the rate is 50%. That's it. It talks about half-life, the rate is 50%. Okay, so we have here our exercises. Let's go to the exercises. Okay, so we will try to solve this exercises, but we will change the value of it. Okay, so here we have number 1. Instead of having 32, we'll change it to 30 peso. Okay, so here, okay, number 1. We all know, let's go back to our formula, which is y equals to a1 minus r to the power of t. Okay, and then the price of copra is decreasing. Okay, so it's another term, decreasing, depreciating, like that, decaying. Okay, decreasing by 5% per month. If the price is 30 per kilo today, what will it be on in 6 months? Okay, so we have here our A is 30, so that is our initial price. Then our rate is decreasing by 5% per month, so this is 0.05. And then the time is how many months? 6 months. Okay, so we'll just substitute it. So 30 minus 1 minus the rate is 0.05 to the power of 6. Okay, so now we will have the answer to this one. So we have to change it into minus. Then this is 30 to the power of 0.05 to the power of 6. Okay, so we already have the answer, which is 22.05. Okay, so as you can see in the decaying or decreasing, the initial value depreciates. It it decrease by a certain amount, unlike the in day one. It is from 5 it becomes 40, from 20 it becomes 37. Okay, so it increased, but here it decreases. Okay, so let's go to number 2. We'll just slash 10 over here. Okay, let's slash 3 zeros. Okay, so I'll read. The value of your car is decreasing by 10% each year if your car is worth 1,200 today. Okay, so let's not be talking about car. I mean your phone. Let's just say your phone is worth 1,200 today. What will it be in 4 years? Okay, so our A is the initial value, which is 1,200. Our rate is 10% each year, which is 0.10, and our time is 4 years. So we have here 4 years, 10%, and 1,200. Okay, so now we have our y is equals to, we're just substitute it with our formula. What is our formula once again? Which is a 1 minus r to the power of t. Okay, so y. Okay, let's zoom in here. Okay, so 1,200 times 1 minus 0.10 to the power of 4. And then we're gonna use their calculator. Our calculator here is 1,200, 1 minus 10 to the power of 4. Okay, 787.32. So what's it? 787.32. Alright, so we're talking about money. So money, it's okay. So it will be this one, 787. So from 1,200, it goes down to 787. Okay, so let's talk about number 3. Number 3. Okay, so once again, our formula. A 1 minus r to the power of t. And then we have here number 3. Okay, instead of having 100 grams, we change it to 10 grams. Okay, 10 grams. Okay, in a nuclear test explosion, 10 grams, let's just zoom in a little bit here. In a nuclear test explosion, 10 grams strontium-90 is released. The substance has a half-life of 32 years. What part of the substance remains after 64 years? Okay, so we have here, okay, so 10 grams. This strontium-90, this is a chemical name, okay? And then we have here 32 years. That is the half-life of it. And then 64 years. Alright. Okay, so we're gonna add something to the equation, which is we put an over and here. Why? Because we have a given half-life of 30 years. So every 32 years, it will degrade to half-life. So we have that as an n. Okay, so we have our A as 10 grams, our rate as, half-life, because it says half-life, so 50%, which is equals to 0.05, and then our time is 64 years, and our n is 32 years. Okay, so let's zoom in a little bit. Okay, So we have here our y, which is equals to, let's substitute it, 10. 1 minus r, which is 0.5. Our t is 64, and our half-life is 32. Okay, that's it. And then we try to solve it with using our scientific calculator. Okay, so we have here 10. 1 minus 50, 64 over 32. So we have here 2.5. Okay, so the chemical, after 64 years, the remaining of the chemical is already 2.5. All right, so that's it for week 7, day 1 and day 2. So I'll make another video for day 3, this one, and day 4. Okay, so thank you for watching. Hope you learned something today, and keep tuning for more updates. Thank you.